backcountry skiers in regards to aspect and how we can make decisions according to our observations?
Yeah, well, aspect is really important when you're looking at avalanche conditions because the direction that slopes face, which is what we call the aspect, is going to dictate what sort of snowpack structures develop there, and also how the weather is affecting the snow on those slopes. So you want to know the aspect of your slopes and how it relates to the sun and how it relates to the wind. And if you look at the avalanche danger rows from our center or descriptions from some of the other centers, it'll show you what the avalanche danger is based on which slope or the direction that each slope faces. And so by knowing that, you can choose which slopes you want to try to expose yourselves to and which ones you're going to avoid.
Okay, so when we look at the danger rows and we see that it's considerable, let's say, from the south to the southeast section, so we know then that, and then it's moderate on the other sections, and our field observations show the same thing, then that generally means that that's the area that we should be traveling in.
Well, if the avalanche danger is considerable to the southeast, then you'll know when you're moving into slopes that face southeast, you want to be especially careful. You still want to use all of your safe travel techniques when you're traveling anywhere else.
Of course.
Because using those techniques all of the time instead of choosing when to use them will save your life when you're wrong. But you'll know that as you move to the southeast, the avalanche danger is higher. Hopefully the forecaster told you why they think the avalanche danger is higher there, and you can start to look for that on those slopes that face southeast to decide whether the forecast really is accurate and applies to the area that you're moving through. But with convexities, there's kind of a couple things going on there. One is that the slope is getting steeper, and so you're changing your slope angle. You're moving onto a steeper part of the slope. Some people would say, don't, if you're skiing and you're going down the slope, you don't want to ski over those rollovers. You want to stop at the top, check yourself. Maybe you want to avoid them, and that's because you're getting on that steepest part of the slope. The other part is that because it's kind of getting pulled over this edge, it tends to increase the tension right there, and so it's an obvious break point. So you have kind of a place that's an obvious break point for an avalanche anyways, and then you add yourself as a trigger point to kind of push things over the edge. And if the stability is close to being, if it's close to being unstable, if it's conditionally stable at the time, and you ski over it, that may be just enough to push it into instability and produce an avalanche. Mm-hmm. The next would be concavity, or maybe the compression. And so that's where at the bottom of the slope, it starts to decrease in slope angle. And what we tend to think there is that there's a lot of support kind of holding that slope up, and so it's a place where you're less likely to trigger an avalanche, both because potentially there's support in the snowpack, but also because the slope angle is being reduced. And so you're moving from a steep slope to a shallow slope, and thus less chance of triggering an avalanche. If you're dealing with a planar slope, a lot of times you have a more uniform structure, and making your problem just slightly simpler, making your very complex problem slightly simpler.
I see.